We learned about nuclides in the previous online lecture. Now what we're going to do is take that understanding and apply it to the reactions that they undergo. So this is how radioactivity is produced. Okay, in a nuclear reaction, what you have is a nucleus, or maybe sometimes there's two nuclei, but a nucleus, time elapses, and then what happens is you have a new nucleus and radiation has come out of it. When we look at these reactions, they're always balanced for mass and charge. So in order to, when we look at it, the mass that you have here is equal to the sum of the mass over here, and the charge that you have over here, the subscript, is equal to the sum of the charges that you have over here. Here's an example. Uranium-238 will undergo alpha emission. So what do we have ahead of time? We've got just a uranium-238 sitting there. Time elapses, and then suddenly, pooh, out comes an alpha particle. That alpha particle coming out changes the nucleus, so now it's thorium-234. Let's look and see how it balances. There's a mass of 238, so the sum of these masses must be 238. 4 plus 234 is 238. The charge is 92 beforehand. Afterwards, 2 plus 90 is equal to 92. So let's look at how you would work through a problem like this, an example problem. It says write a balanced nuclear equation showing americium-241 decaying to form an alpha particle. Well, the first thing you would do is write down all the information for americium, then draw an arrow, because in emission you have this, and then afterwards you have a particle and a new nucleus. Well, it says alpha particle, so it must be an alpha particle that is emitted. Let's try to figure out what this nucleus will be. 241 has to be 4 plus something to give you 241. Well, that must be 237. 95 has to be equal to 2 plus a charge of something that will add to 2 and become 95. Well, that's 93. So when we go to figure out that particle, we write the 237 and the 93, then we use a periodic table and look for something with an atomic number of 93. Well, that's neptunium. And that's how you would balance one of these reactions or write it from words. Here's an example of beta emission. Carbon-14 undergoes beta emission. So here's carbon-14 all by itself. Then over time what happens is one of those carbon-14s will spit out a beta particle. A beta particle has a mass of 0 and a charge of -1. So the other particle has to be whatever mass would add up when added to 0 would give you 14. So you put a 14 up here. Then, because this is a -1, whatever is added to -1 to give you 6 must be the atomic number here. Well, that's 7, so there's a nitrogen 14 that is made. And if you look at this, this nucleus here, you can see there's 1, 2, 3, 4, 5, 6. One of the neutrons is going to spit out that beta particle. Which neutron is it? This one, you can see, changes blue to a proton. And what happens is this little beta particle comes out, and that neutron here became a proton. Carbon-11 undergoes positron emission. So here's carbon-11, and what does it do? With time, it spits out a beta particle. Notice 0 plus 11 is 11. Positive 1 plus 5 is 6. It's balanced. And you can see here, this is the proton that became a neutron. In gamma emission, a gamma particle has no mass and no charge. So the atomic number and the mass number do not change. This is something called a metastable isotope. The M is put here to say that it's high energy. And what actually happens is 99 becomes 99 because this is 0 here. 43 becomes 43, so this is 0 here. So basically, the element is not changed except for the amount of energy in it. You know, the protons and neutrons were arranged in such a way that it was unstable and they changed position, and then that gamma ray comes out. Okay, so now here are 3 equations, and what I want you to do is find out what are the missing particles here. So you're going to use your understanding of, you can figure out an atomic number here by looking at the periodic table. By understanding what are the characteristics of an alpha particle, you can put the numbers over here and then balance the numbers, and then you'll be able to figure out what element this is or what particle this is. So go ahead and try these reactions. Okay, the first thing that you do is you fill in the missing numbers so that you can balance it. Radium has an atomic number of 88. An alpha particle is a helium nucleus with a mass of 4, so 4, 2. Hydrogen has an atomic number of 1. Helium has an atomic number of 2. Cobalt, 27. Now we do our math and we figure out 226 is equal to what plus 4? Well, that must be 222. 88 is equal to what plus 2? Well, that must be 86. All right, we can do, now we can take this 86 and go to the periodic table and look it up and see that it is radon. If I go here, 3, that must be a 0. 1 is equal to 2 minus 1, so it's a beta particle. Cobalt is unchanged except for the energy, so what do we get? A gamma particle. So how do you write an equation from words? Here's an example. Uranium decays into thorium with an emission of an alpha particle. First, you write the uranium. This is uranium-238. The radioactive nucleus is going to make radiation or particle and a new nucleus. So it says alpha particle, so we write the characteristic, we write down the alpha particle. Now we do the math and we figure out 238, 4, that's 234, 92, 2, that's 90, so that's thorium. Remember, sum everything up and make sure it balances. The element changes because the number of protons changed. So what is the equation for technetium-99 emitting a gamma ray? Well, first thing you have to do is write down technetium-99. Then you know it's going to be emitting a gamma ray. Well, 99, 43, and a 0, it must be that it's 99 and 43. This will be a little bit more challenging. Write an equation for a neutron colliding with a molybdenum-98 nuclide. In a collision, the neutron's going to be on the left side because it's hitting this nucleus, and it's going to make a new nucleus. See if you can write this equation. Well, we have molybdenum-98 and a neutron. They're going to collide together. They're going to make a new nucleus. 98 plus 1 is 99. 42 plus 0 is 42. So it ends up making molybdenum-99.